Hi, I'm Alan Ross. We're going to be talking about grid automation. Uh, Today, my two guests are people that when we were deciding who we could ask for this, um, they were the top two that came to mind. We did have a third person that we wanted to invite, and then we said, no, I know these two gentlemen, and I'm pretty sure that they're going to be enough. Eric Thompson is with Iris and E-Sentry. You'll hear about that in a little bit, but Eric has probably taught me more and in our times together, either on webinars that he's done or just in person. We do get to see each other at least once a quarter, and he is, as I would say this, he is looking at the future as it looks to safety devices, which Iris is one of the leading edge people for companies for that. But his ability to simplify complex situations is well appreciated. My next guest is Mark McVey, who at the same time, Mark is with Dominion Energy. But if every time I needed somebody to really explain where things were, because they're engaged in so many parts of the industry, it would be Mark. We were just talking before we came on that Mark was recently at Lake Como, Italy. He did not invite me. That was fine. And Mark, where were you at Lake Como? What were you in again? You were in some conference.
It was the technical council for SEGRE. All the study committee chairs meet before the general meeting in Paris this year. Every 2 years, we have the big meeting in Paris. So we were organizing, and so we had a breakaway session, and we got to go see the most incredible shrine you ever want to see to an engineer.
No, tell about that because there are a bunch of engineers on here, and I was fascinated because I didn't know it existed.
Yeah, Alexander Volta, of course, we talk about potential electricity called a volt, and that was the area that he was actually from. And it was really a center very much like you have in the early 19th century with the development of AC, DC, and all. But at that time, he was communicating with Benjamin Franklin,
Wow.
Galvin, and he were back and forth on things. And so it was really the most incredible building and fascinating thing when you talk about the different types of batteries and static electricity. They have a whole bunch of his inventions that are there, but the marble staircase and everything is very imposing sitting on the lake. It's quite something.
Sitting right near George Clooney's residence, um,
Right across the lake. Yep.
across the lake. So it's interesting when you talk about Lake Como. If that were an IEEE event, maybe you'd get 50% of the people that you invite, like whether let's just say it's a transformer committee meeting, you get 25% because it's a long way to go, it's expensive, and most bosses are going to go, no, 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 you're not going to Lake Como because at Seagrey, it's in the backyard. And I bet you it was 100% participation of the people on the committee, right?
Well, yes, of the council, we only had one person that came in remote, and that was because of complications of travel due to some world events that are going on.
Yeah, okay. Can only imagine what those are. Let's get started on this, and I really appreciate it, gentlemen, for you being here. The first question is about change, and we have been hearing for several years now, maybe five it started, but the grid is undergoing more change today in this time frame than it has in the 50 years beforehand. I think, Mark, you and I were talking about when we came in to our schooling, engineering was boring because electrical engineering because we'd go to utilities, and now we wanted to be into electronics, and now electronics and utilities are merging. But why are we undergoing so much change? What is the cause of it? Start with you, Mark.
It's actually a trifecta. It started early, more than a decade ago, as we were going through the updating of aging infrastructure. You know, after World War II, there was a lot of push to interconnect these utilities that were primarily satellites. And that infrastructure has reached its end of life. So we started that. Then the grid transformation came as we tried to have everybody push to try and get to where the CO2 is going to be at zero in 2050. And then suddenly large loads appeared, this monster AI. when you topple all that together, it increased over the ability of the supply chain. And so you have supply chain issues. And then, of course, we don't have the people for this unprecedented growth since World War II. So that trifecta of things is really what is impacting the grid right now, is that we've got these rapid loads, rapid changes in generation, aging infrastructure that all has to be updated. And we need the educated people in order to be able to do that with the new systems. And all the materials and everything have changed as well. So those things that we talked about when I came in, we're using different oils, we're using different glass, we're going away from porcelain to composites and polymers. And so there's a lot of unknown that's going on with this as well. So it's probably the most exciting time in my career to actually be in the industry. It's one of the reasons why I chose not to retire.
Yeah, that's actually, this is my third retirement, and I keep trying to get out, but they keep pulling me back in. Eric, one of the things that, Mark just alluded to, everything's changing. You brought a different perspective to me, both at the industrial, it's industrial, and I would include data centers in that, commercial, and utilities. And that is this emergence of electronics being part of it. But there's another part of that, and that is everybody wants everything to be monitored. If we can put a monitor on everything, then we don't need people. The machine can tell us. I mean, that used to be one of my mantras. Let the machine tell you it's sick. Don't have a guy or an operator tell you it's sick. Don't have to go out there every year and do one check. And if it happens not to be sick on that day, everything's okay. Well, it decided that it got sick the next day. Talk a little bit about that and your role at E-Sentry.
Yeah, so we're definitely, if you talked about like what is happening in the last 50 years and is the grid going under change? And yes, it definitely is. And so from an IoT perspective, it gets really interesting because as the grid becomes more complex, visibility becomes critical. So you really need to know what's happening in the field across substations, feeders, transformers, switchgear, all of these critical electrical assets, and even at the edge of the grid. So that we get these connected devices, sensors, communication, data, and automation really becomes important. And this automation is just not dashboards. It's seeing this data and making it actionable. So it gives the operator a better picture of what's really happening and really help them make better, faster decisions. So with this transformation with the grid and especially, IoT, Internet of Things has been around for years and years and years. But what you can do with that data now is just really, really exciting. Exactly what Mark said, right? It's amazing what you can do with the data that you get from these sensors and connected devices.
I think it's interesting that we talk about one of the good things about AI is we'll be able to pump data into it and create these systems, agentic systems, and but the problem is they are requiring so much power, which is your third point about why we're going through much change now, Mark, is it's just gotten unfathomable about the demand for power that none of us projected 10 years ago, right? We thought it was a nice steady
5 years ago.
5 years ago, yeah. It's the hockey stick now. I was talking to a lady who is in charge of, I'm not allowed to say her name because I'm going to say something she said, and it'll sound like, hey, you shouldn't be sharing that. But she was talking about how they were caught unawares. And in their system, they were hoping that their nuclear facilities could handle the extra load. They're sold out. And it wasn't like, oh, you can handle that load. I think that's why, is it Microsoft that bought 3 Mile Island, I think?
I do not know.
I believe you're right.
That sounds right.
Yeah, sounds right. Yeah. When Microsoft buys a nuclear facility, something is going on, right? Let's go to this. Not everybody defines everything the same way because there's two definitions I want to go to. The first one is grid automation. I mean, I hear it, and I'm in different pockets, and I hear different people it's like this, it's an elephant. Some people hold the trunk and thinks it's a fire hose, and some people hold the tail and think it's a rope. It's an elephant. Talk about the fact that it's an elephant, Mark, and what to you does grid automation mean?
Grid automation is actually what we've gone from condition-based monitoring, where you talked about us collecting data, and we were great at collecting data, but at one time, but not doing much with it. Now utilities and groups and consultants are doing analytical teams to be able to use that data real time. And what that does is many things that can happen in the system, particularly with large loads, that the operators cannot quickly manually go and make those changes. And so you need systems in the grid that can automatically take care of those conditions. Something like a unified power flow controller, which is a grid enhancing device, operates on its own in order to maximize flows, specifically in this case where the market generation would be best suited from one location to another because the impedance of the system doesn't allow the flow. Well, because it does it on the fly, it can take care of the problems that an operator trying to maintain voltage at a specific level to make that transfer take place. It does so automatically, so he can go off and do other things. StatComs are a perfect example of grid automation, because before the operator has a chance to, say, trip capacitor banks offline because now that you've had a large load rejection because, say, 50 data centers, for whatever reason, decided to leave the grid, then you can actually moderate that voltage instead of the operator trying to go around and trip a bunch of cap banks off. So these systems are ways to, just like traffic lights, take care of things automatically so that the operators can work on studies and other things in enhancing the grid to alleviate these conditions that will pop up from time to time. Now, that's just an example of that type of thing. There are also automated systems that you work in the background with the data that you're pulling in that can tell you whether or not you have problems, say with a transformer. Instead of just getting an alarm, it'll actually be able to pull that information in and say, hey, this transformer needs to be taken out of service, and it'll automatically call the people that are responsible for that area for them to be able to come out, not only take it out of service, but to do whatever analytics might need to be taken care of. It'll tell you what the dissolved gases are, so you know whether it's something you can return to service or you need to start making plans. So those systems exist today, and we're trying to rapidly move that into the system. But as you mentioned before, what Eric's talking about, you need the communication infrastructure in order to be able to do some of that. And that's part of the big push for us, is get not just fiber everywhere, but also systems like private LTE, being able to do those things, offshore with offshore wind and things. It's a multivariate problem. All these things are working at the same time, but the automation is something that operators don't have to take action on based upon what they see on a dashboard. It takes care of it itself.
Eric, same question, follow up on
Yeah.
Mark's answer.
Yeah, so I would define grid automation. It's pretty simple. To me, it's helping the grid become more connected, more visible, and more responsive. Exactly what Mark is saying. It's the ability to monitor what is happening, understand what that data means, and the most important part is take action faster. So in the past, a lot of grid operators, were more reactive, and something failed, a customer called, a truck rolled out. And then the utility, started identifying the issue. So grid automation, helps shift that model. It really gives the operator just better visibility before and during and after an event. So that's really where IoT naturally fits in, right? So IoT is this, the nervous system of grid automation. You have sensors, you have connected devices, collecting data from assets, from like switchgear, breakers, substations. and then being able to take that data and make it actionable. So I guess to break it down, the three parts would be: first, visibility. Can you see what's happening? Second would be intelligence, right? Can you understand what the data is telling you? And third is response. Can you act on that information through alerts, workflows, automations, dispatch, and so forth? So if I had to put it in one sentence, I would say grid automation is really the use of connected assets, sensors, communication, software, and intelligence to just show more visibility, resilience, and being more effective with what you're doing with that data.
I hope you wrote that one sentence down. Please send it to me, okay? I want to feature it in what we're going to do when we do something with this. An interesting thing, I just thought of this, so I'm going to go a little bit of a rabbit trail and ask you some questions. The biggest thing that I think is happening at, let's just say, in the boardrooms at the C-level is what you both described is going to require an enormous amount of trust. When you let the system and automation make a decision to bring an action about, right, where you're not having an individual. We haven't lived in that environment. This is a completely different environment than most people have been through in the utility and in the industrial spaces. They want an engineer to get the data, sit down in a boardroom, talk to 10 other people, and make a decision. And what you're saying, Mark, is they don't have the time to do that anymore. I mean, you need the system right there. And it's the idea that the system would make a decision and actually take an action. Talk a little bit about culture change and what is going to be required so we don't stop all of this wonderful stuff at the board level where the CMO, the chief marketing officer, says to the CEO, "We've never let the machine tell us what to do." That sounds like it's suddenly the Russians can come and hack us and make decisions. I mean, it is a level of trust that has to happen with this change. I'll start with you, Eric.
Yeah, so exactly, right? You can have this technology, you can have this automation, but you have the C-suite, you have management teams, you have the field operator. So the C-suite usually defines automation around business outcomes, right? They care about the reliability, resilience, cost reduction. The management team usually defines operations around automation around operations. And then the field operators and technicians, right? It's how is this data going to help me? How is it going to make my job easier? So it is, you still need humans in the automation process, right? But you don't, you just need someone to not really, spend a ton of time, maybe not knowing what that data is, but just being able to have that experience, that tribal knowledge, to be able to look at something from an automation standpoint and be like, yes, go ahead and do that. But yeah, it is this trust where, how far are you going to let, automation go without human interference or human checking on it?
Oh, I love that because, Mark, you are that guy at Dominion Energy. You are that human that they say, hey, the system made a decision. Was it the right decision? But it's in retrospect when you do that. Talk about the change that you're seeing, even within your own organization. It requires a lot of trust to install these systems, correct?
It does. And, the culture is changing because of the temperament of the people that we bring in. We don't have any choice but to look at innovation, whereas it used to be something that people put off. We've been doing it that way for 40 years. What we're doing works. We don't need to change. And we don't have that choice anymore. Regulatory requirements to change the mix in generation and to change your assets. And then we have to accept all loads. So that piece of it, you need that piece of innovation in there versus people that, we've always done it that way. We're going to continue to do it that way in the future. We've been very blessed that we have management, and I'm seeing more of this across the world too, that they're willing to invest in technologies like real-time digital simulators. And we just built the first high voltage lab in probably 50 years in the US. It's to help us manage that risk that we have with the new products, the new environments. We can test systems out, this automation that we're talking about. It's not just something that we put in and then we're going to see how it reacts. We can actually emulate the grid and make it think that it's hooked up to the grid, and then we can throw every fastball and curveball we want at it before it goes out in the real world to be able to try that out. These systems, we didn't have this stuff 20 years ago. So that's really what you see, that the people that are in the top positions are looking to manage that risk. And that's part of me as an engineer. We always have to look at, is the juice worth the squeeze?
Is the juice worth the squeeze? Right. I like that one too. I'm going to be able to use that one. I will give you accreditation for it though, Mark.
I heard it somewhere. It's not mine.
Well, it's never half the stuff I say somebody else said, and I act like I made it up. I want you mentioned something about governing authorities. We live in the United States. We have 50 different authorities. They're called the state regulatory boards, public service commissions, whatever. We have the Department of Energy, we have FERC, NERC, and a whole bunch of other things regulating the way they've always done it. And many of them are political organizations or they're impacted by politics. Talk a little bit about the struggle that utilities have, particularly because you've got more regulators within the utility market than I think. Maybe the only other one would be airlines, but they don't have 50 state regulators doing anything with airlines, right? It's pretty much the FAA. But talk a little bit about governing authority. What has to change at that level to allow some of these really large-scale changes take place?
Wow, that's really a question that is constantly being looked at now. After the 2003 Northeast blackout, you finally had a federal organization put together all the transmission organizations. And so they're regulated under these critical infrastructure protocols, handling both digital and physical security. But at the distribution level, you have a lot of distribution service organizations in the U.S., more so than anywhere else in the world. And they operate independently. And the states don't all agree on what is the requirements. And so IEEE and organizations like IEC and CGRE were the opportunity for both the customers and the utilities to get together and formulate some rules. A perfect example of that was, the rules that IEEE put under IEEE 2800, which has been adopted by NERC with a new standard specifically for inverter-based generation. That these devices have to be able to ride through some of these events that occur in the system, and that's an example of where at least the technical voice and community has gotten together, where some of these regulators are looking at. There probably needs to be a push in cyber. Each one of these state regulators are really looking at the DSOs and their cyber requirements, which is smart, but we're not quite there. We're not where we are on the federal level with the SIP protocol requirements that we have. But also now these large loads can impact the grid as well, but there's no requirements quite yet unless there's something in the facility interconnection agreement that each utility has with these large loads. And because you've got hyperscales that are all linked up together, that's a new threat. So these are threats that we hadn't seen before, and we haven't been able to quite adapt a structure to be able to handle all those things because it's not regional anymore. Think about it. In the 1980s, each utility had their own generation structure, and so that we could basically open the breakers and isolate and run by ourselves if we wanted to. That's not the system of today. And so what happens, say, in 3 states away can impact what's going on in my service territory. And so we still need more regulatory requirements there. But I am pleased that the communities recognize these threats to the grid, and that we all are trying to get together to see what we can do to create standards or agreements on how we're going to handle these going forward.
Eric, you've got the same thing because you have in many of the things, it's just not the regulatory for utilities. It's boards of directors at companies and C-suite people that have been doing it the same way. And as Mark just said, that's the way
Mhm.
we've always done it, right? So the question is, why don't you adopt these things that are going to help you? Well, because that's the way we've always done it. So we're going to continue to do that. Do you see the same kind of problem, but in a different area as you look at the industrial commercial world?
Yeah, so affinity to change, right? You have certain industries that, we've been doing it for, decades and decades, and it takes something, like the, COVID, where you didn't have humans and you didn't, you needed technology, you needed automation. So I think unfortunately, COVID kind of helped some industries, lower those barriers and start looking at technology to help their organizations. So for me, really the first step is aligning around the outcomes, right? Like what is the utility, industry trying to achieve, the industrial trying to achieve, right? From a grid standpoint, do we want a more resilient grid? Do we want a more affordable grid? So aligning on those outcomes. And then from an IoT and automation perspective, yeah, exactly. We need to just have common expectations around cybersecurity, interoperability, data and governance, and just, we don't all have to use the same technology, but if we can all kind of, in the industrial world, have the same, outcomes that everyone that will help everyone from using automation and IoT and technology. So yeah, it's still a struggle. You still have folks that just don't want to change. But as these events happen and you get these, they're not science projects anymore. These are real, true ROI outcomes of implementing IoT, implementing, automation and so forth. So yeah, it's getting better, but it's still, we got a long way to go.
I'm going to ask a question from the floor before we continue because I think it's good. But first, I'll say this. The first question that I got from the floor was, I absolutely agree. I love that. This is not a question, by the way. I absolutely agree. Data is becoming the backbone of smarter grid automation and reliable power, while also helping prevent failures and potential problems. I wish I knew who sent that in. I could find that out after, but whoever you are that sent that question in, thank you. You're right. Everything that we're talking about is exactly where they are. Another question, Eric, I can't believe how it works. You just brought it up, so I have to ask it now because I'll probably forget this in 15 minutes. There are a lot of outcomes. You talk about resilience, reliability. We hear more today than maybe in the last 5 years. Hey, all of this wonderful stuff is happening, but it's not affordable. You're making power unaffordable. Data centers, especially AI data centers, are going to cause a rate increase for your ratepayers in Northern Virginia, because you got a lot of data centers in Northern Virginia, right, Mark?
We
And
do,
so
largest in the
the
world.
largest in the world. And so the requirement for power, if that does cause the affordability issues, talk a little bit about that affordability. And Eric, since you're the one that talked about it first, you're the one that has to answer it first. How do you
Yeah.
balance affordability with resilience, reliability, sustainability, all of those things?
Yeah, it's not easy, but the good thing is that the technology, is more affordable, right? It's not 10 years ago, 20 years ago where you had a bunch of CapEx, you had to have be a certain size company to really invest into technology that can help with automation, can help, your operators, just help your overall organization if it's utilities, industrial. So I think one to be to have a more affordable, is reducing your costs through technology, which is number one, right? So I think we're in a very good space where, AI is affordable to a point, you don't need millions of dollars to invest in technology and solutions that can help bring extra value, reduce costs to your end users and your customers. So it's probably where I would say where affordability, you kind of have this, yes, investing in technology, it's a lot less expensive, but again, that affinity to change, these industrial utilities, they need to see the value that it brings to their end customers, where reducing their costs, is brought onto, me. I've seen my electricity bill go up 30%, and we haven't done anything different in 2 to 3 years. So hopefully, being able to utilize technology to bring that affordability to end users.
So, Mark, Dominion Energy is recognized as one of the leaders in this whole area of automation and meeting demand. And as you say, largest in the world AI data center collection, a lot of demand. How did that happen at Dominion Energy? How are they able to make the ratepayer in Alexandria, where my wife was born and raised, happy enough? They may not be perfectly happy. They wouldn't like 30% rate increases, but you've got a very diverse rate base. Talk a little bit about how you've been able to do that.
Well, there's a couple things. One, I wanted to let you know that the state legislature has passed rates specifically so that those costs for upgrades in the transmission system are not socialized among all of the residential customers. So the legislature has seen the need for a change in the way the rate structure is, and I think that's part of it, is to make it more fair for those people that need large loads that require system upgrades. That they need to pay their fair share. But the other piece of it is just an all and above approach for generation. So not only are we investing in renewables like solar, and we're building the largest offshore wind facility in the United States, but also looking at small modular reactors, looking at additional gas facilities where it makes sense. That's part of the issue. There is where maybe you can build a power station. You need to be able to have a good, strong transmission backbone in order to be able to deliver that. And that's one of the things that we've done really well at Dominion, is enhance our transmission grid in order to be able to bring cheaper, reliable power. It's whatever the market is going to pose at that time. And that's really what's helped us keep our rates lower than, say, many of our neighbors. And that's part of the reason why we're attracting the large loads is resiliency, lower rates. There are tax incentives, but a lot of it also has to do with infrastructure upgrades that took place in the 1980s. Back in those days, everybody was putting fiber in because they wanted to sell streaming to people. You probably remember when, it was great when we first got cable, but maybe the program you wanted to watch came on at 2 o'clock in the morning. Well, there was a big fight among companies to provide that streaming service, so that backbone was put in. So that made it cheaper for those loads to come to our service area. And so now we're having to try and figure out how the best way to plan for those to provide the most reliable, least expensive, as well as clean power. You say not resilient, but sustainable. And really what we're trying to do is deliver that clean power. So it's a challenge. There's no question about it. But the key there is also attracting some really smart talent. When I first came into the industry, we didn't have PhDs necessarily, certainly not at the engineering level. We had a lot of good, smart people with bachelors, but now the complexity requires people with different tools. And so we need those people coming in that have advanced tool sets to be able to help us plan and figure out what's the best way to meet this load in order to keep the lights on, to make it affordable and make it clean.
Okay. To a switch, we've covered a lot of these. So if you've said it before, don't worry about it, because we'll capture these in a. I'm always interested to learn, hey, we've got all this going on. What are the real challenges to actually bringing about, I would say, true grid automation? But how we would define it, Eric, to your point, whatever your outcome is, what do you want? We can define that. But what are the challenges? You just mentioned one, people. Mark, that if we don't have smart people and they're not coming out of think tanks or schools or wherever they get it, and it can't be just which then affects the curriculum at a school. You better make sure that you're teaching the next generation of double E what they need to know now, as opposed to teaching them the old way, which is what happens at a lot of school. And a lot of guys get to their third year, they just want to graduate and get a job. But did you learn what's happening right now? Talk a little bit about educating the next generation. Where's it going to come from?
Well, part of it is, we didn't hire when we were moving towards a competitive environment. The federal regulators thought that they could do to the utility industry what they did with the airline industry. And when they started having blackouts in California, all of that changed pretty quick. So they more or less re-regulated the system. But for about a 10-year time period, utilities didn't hire young grads. So a lot of the universities around the country, basically at the undergraduate level, stopped teaching power, because why teach power when there were no jobs? And so that's one of the things that we're still trying to recover from, is building those programs back up. We have large engagement with the universities regionally that we have here, and working with I'm on the ECE board at Virginia Tech, but I also am in contact with George Mason, which is building a strong university there, and we're trying to influence what courses and what technologies that they have at the university. And we're trying to do that regionally. There's other people that are copying that same model. So the key is to build the base back up at the university level and provide those courses. And some of them will be new courses and new technologies. And that is coming in place, but we're probably 4 years or more behind where we need to be right now in order to have the people that are going to design the grid of tomorrow, or at least the plan that we have going forward to make all that happen. And it's not just, we're not talking just bachelors and PhDs, but also technicians, the craft people, all of this process. We need all of the above people, and not just engineers too. Some of the best people that we have that are project managers are not electrical engineers, but they're critical people to make sure that these projects get done. But there's so much coming down the pike that the process that we have is not fast enough to meet the needs of the load that we have, and we can't get the equipment that we have. So supply chain is one, the intellectual property is another. And then, of course, we're learning about the aspects of these new loads like data centers or what their impact on the grid. But we're also getting the ability to utilize that intellectual technology to help us better do asset planning, and then, in the future, helping us learn to run the grid. That goes back to the automation piece that we don't know that we'll ever automatically turn things over to somebody else, but systems that run in the background to help you make decisions, those could be in real time rather than taking an hour or 2 hours to calculate.
When you said you started the sentence when you said turn things over, I thought you were going to say turn things over to the robots, but to other people to manage it. Eric, same question, challenges that you see going forward.
Yeah, exactly what Mark has saying, but really it's, you have aging infrastructure, you have that rising demand, even extreme weather. So you have all of these different loads now that just aren't, like how they used to be. It's just not a one-way system. So for me, it's visibility, right? As we get better with capturing data and knowing what to do with that data, I think visibility is a big challenge right now. But obviously, I think with automation, grid automation, AI, IoT, that is going to help with that complexity. And then so complexity, right? The grid is no longer, like I said, a one-way system. Power is moving multiple directions. Assets are way more dynamic, and the conditions are changing faster. And then the third I think the challenge is speed of response, right? Like when something happens, operators really need to be detected quickly, understand the impact. So again, like automation, data, AI is helping all three. So from visibility, complexity, and speed of response. So I think you're going to see these challenges, not be 100% resolved, but being able to get data and make that data actionable, I think is going to be really help this industry and that grid automation.
Excellent. Thank you both. I'm going to take another question from the field. This is not a statement because it starts with, wouldn't the cost of the equipment be offset by the savings on unnecessary replacement of equipment achieved through condition-based maintenance, eliminating waste that comes with time-based replacement, simply replacing equipment because a book says so, or in my case, the calendar says so? These technologies allow providers to make smart decisions and should, as a byproduct, reduce OPEX or CapEx. Good question. Mark, start with you. You see a lot of that at Dominion. You're having
Well,
to
it's
change
already,
out.
yeah, it's among the larger utilities, it's already taken place. It requires capital investment as well as manpower to implement those things. So like transformer monitoring, breaker monitoring, those technologies exist. We have consortiums that, help us manage that data in order to be able to see where the end of life is. We have actually an IEEE standard that tells you how to do the calculation based upon the moisture and the gases that you have, so that you know that you're close to end of life, so that you can replace that asset before failure reasonably. That's really the golden ticket for us. Is we want to run it right up to the edge of end of life and replace it before we have a forced outage. We're working with companies to develop other things like monitoring on capacitor banks and monitoring on arresters. Those things that might be considered minor items, but that can have impact on the grid. So a lot of that is taking place, at least at the larger utilities. There's still a lot of investment in the distribution end because maybe their business model doesn't support it. And so some of that really depends upon the actual business, whether they're a type of generation, whether they're transmission, whether they're distribution. At the transmission level, at least with the FERC rates, where we could be charged $1 million per day per event if they see that we're being negligent. That's a strong incentive in order to be able to put these systems in, to be able to do condition-based maintenance. But the next step is reliability-centered maintenance from that. And that's where the automation comes in, running in the background, to be able to, rather than just produce data from condition-based on a spreadsheet, and then you try and put all this together, you can actually have systems that will look at, they might look at designs, they can look at test data across the entire fleet of transformers, say, that you have, and then help you make decisions. If I only have X amount of money for replacement this year, how can I get the best bang for the buck? You don't get opinions in that necessarily, you get results. And so those types of things will help us. So absolutely agree. The more of that we can get in moving into condition-based maintenance, but also go into reliability-centered maintenance is the next step where we go after we collect this data, that we find ways to help the asset managers do the best that they can for reliability of the grid.
I know, Eric, your organization does a lot around reliability-centered maintenance, changing the way people look at, from whether that's a utility or an industrial. Some of these industrials are like big cities, right? Or excuse me, small cities. They're sucking in a lot of power, and they're at the end of the food chain. So they didn't put slots in to get transformers, right? So they have an existing system that they've got to be able to maintain as long as they can. So that, just because something hits day 512, it's taken out of service. They're not going to do that anymore. They're going to depend on RCM. Talk a little bit about that.
Yeah, so really it's what you're able to do with the data now. It's from different siloed systems, right? So you might have sensor data, you might have like PLC data, and you're able to get that data analyze that data and start using it. And Mark kind of alluded it today or on this call is digital twins, right? Simulating what you're able to have this data about this asset, and then you have a digital twin, and now you're able to see like what will happen in the future, if you get it to this load or, whatever you need. So being able to have separate data now into one kind of form to analyze it and really start doing predictive maintenance or understanding, the longevity of that asset. So really it's again, being able to collect that data from any asset and really utilize, the AI and Gen AI to really, really start doing predictive maintenance on that asset. I think it is one way where instead of, we're moving away from time-based, obviously condition monitoring, you're getting that data, you're getting that work order data, you have that history of that asset. So you're really able to do a lot with that information and that data to really prolong your assets. And that's exactly what we do with Iris, with E-Sentry, right? It's what you do with that asset data. If it's sensors, work orders, and really understand where that asset is in its life cycle.
Next question we've got, and I'm glad somebody was listening, but and with this question we're gonna come to an end on this. But Mark, you mentioned Seagrey and Seagrey Paris and being in Lake Como. As you look at Europe, what's happening in Europe, you mentioned also that like in the United States we have a different regulatory environment, they have a much more centralized approach, even though each country is its own. They have a different way of doing it. What are the similarities or the differences between how it's working in Europe and how it's working in the United States?
A lot of it is it's total from top down to the bottom, where we used to be where you weren't siloed between generation, distribution, and transmission. You still have that in Europe, but you have the EU that basically sits on top of that. And the focus in all three of those areas have been at renewables, but also creating a regulatory environment. For instance, in eliminating things like SF6 gas, which is an insulating medium that we've been using in switching devices for 40 years. It's been labeled a greenhouse gas. And so they've very aggressively gone towards replacing that. So they're really focused on those things that environmentally, like PFAS as well. The regulations that they've put together on that affect all of those European utilities and manufacturers as far as having to come up with new materials in order to meet that and specific lofty goals for renewables in the grid, whereas the U.S., rather than forcing that, the U.S., at least at the federal level, has tried to make incentives for utilities, making loans and incentives, tax incentives to promote that among utilities, not really forcing anything. And, California has created a regulatory environment in the state towards things like SF6, but that hasn't taken place universally. So just a different focus from the top down as far as what needs to be done, because they still have a lot of impact at the EU level on, say, the DISCOs or the DSOs that we do in the US, because those are run by the states. That's I guess the kind of the nuance that you have. There's other things from a regulatory standpoint of training for employees and things of that nature that are quite different in the way that they're handled around the world. And that's what makes writing a standard or brochure on a worldwide scale very difficult, because there's a lot of diversity in the approaches that we take to grid management.
Excellent. Great answer. Gentlemen, it has been tremendously insightful. I appreciate it. Mark McVey, Dominion Energy, thank you for doing this. And Eric Thompson with Iris E-Sentry, thank you for doing this. And we are going to close out now. We will produce shorts of some of these, by the way, which will be take one answer and push it out. And we get thousands of people that listen to the shorts that then drives them to the long form. But thank you very much. This has been tremendously helpful. This has been an APC Media production.